Good morning, my YouTube viewers. Crystal here. I decided this morning that I wanted to do a code review on something that I was working on yesterday. Basically, what I wanted to work on was the daily temperatures for Melbourne, Australia. That's the data set that I was working on. And the reason why is because I'm still trying to work on this multiple time series forecasting, and so I haven't had a whole lot of luck with that, but I still keep trying. I was able to do it with FBProphet, but not able to do it with Statsmodels. So I'm trying to do Statsmodels with multiple time series forecasting. But in the time being, I found another data set that I wanted to go over that I worked on, and I wanted to go over a code review with you on this. Now, this particular data set, I was inspired to get it from Jason Brownlee's site because Jason Brownlee used it for something. But even though he used it for something, I couldn't get the program that he wrote to work, which is the problem that I found so often. One thing about Jason Brownlee is he loves functions. Almost everything is a function. And I'm not really a big function person. I like to do things very straightforward. And because he loves functions, it is quite difficult to read his work. It's quite difficult to back program his work because almost everything is a function if you look at his work. But I couldn't get it to work. I took his program. I found a CSV file of the Melbourne temperature data, and I copied and pasted his program into Google Colab, and I couldn't get it to work, which is another problem. Like whenever I'm looking at the work of other people, it doesn't work, and so then I have to try to get it to work. So I have to spend a lot of time troubleshooting it. So this daily temperatures in Melbourne, Australia is one data set that I got off Jason Brownlee's site that I couldn't get it to work, but I worked on it and I got it to work using other code, and we're going to do a code review on that. So basically what I did was I wrote this program on Google Colab. Google Colab is a free online Jupyter notebook that has many of the libraries already installed on it. And so because of that, you don't have to install anything. You just import it. And I don't get anything at all for promoting Google Colab. I wish I did. So what I did was I imported Pandas as PD and NumPy as MP, which are two standard libraries that you're most always going to need to use whenever you are writing a Python program. I mean, I suppose you could write a program just in Python, but it would be more difficult and a lot harder. So, and then what we did was we read the file in, but the file had some errors in it. So since the file had some errors in it, you had to put in the code error bed lines equals false. So that's what you have to do. You have to put in that code to actually get it to work. So then what we have is we have a univariate time series data set. So you've got the date and then you've got the temperatures. So you've got the daily temperatures in Melbourne, Australia from 1981 until 1990. So we look at some information on this site, and you can see the date and the temperatures are objects, which isn't right. They shouldn't be objects. So the first thing I did was I renamed the column from daily minimum temperatures in Melbourne, Australia, 1981 to 1990 to temperature. So now we just have date and temperature, which is easier to work with. And then the reason why the temperature column was an object column is because it had a question mark in it. So, that was the problem, the question mark. So I had to put in the code to actually remove the question mark. So series temperature equals series temperature map lambda x dot L strip question mark. And lambda is like an internally defined function. It's kind of like a really small function that you can write. And so that's what it is. It's lambda's really small function that you can write. So lambda x equals x L strip question mark. And then we checked on the info again. And in this instance, what we did was after we removed the question mark from the data set, we made temperature column a float. And then we checked what type of file it was, and we can see in this instance the temperature column is a float, which is what we wanted. And then so we've got series plot, pie plot, show. So this was just a really easy plot, and so I decided to leave it in there just to show you how easy it is to actually plot a graph. You just do series plot, pie plot, show, because this is a time series analysis. And then now what we're going to do is we're going to rename the columns. And the reason why is because we're going to use FBProphet on this. And because we're using FBProphet on this, we have to rename the columns to something that Facebook wants to see. Facebook wants to see DS for the date and Y for the temperature. So now we just got two columns, DS and Y. So now we're going to graph it again. This is just a little bit more complicated way to graph it because it's got labels on it. And it's just, it's a little bit more elaborate than the first diagram that we made. And you can see that the temperatures are cyclic. And of course they would be cyclic because if you're taking the temperatures every day, well, the temperature is going to vary every day. So that's very interesting. So now what we're going to do is we're going to split our data set into X-train and X-val. So X-train is everything before January 1st, 1990, and X-val is everything on or after January 1st, 1990. Now we're going to use FBProphet to make predictions on this data set, and so we're going to import Prophet. So model equals Prophet, model fit X-train. So we're fitting X-train into the model. So now we're going to make a forecast on X-val. So forecast equals model.predict, X-val.drop, columns equals Y, forecast. So we're using X-val and we're dropping the Y column. So you can see that the DS is the actual date. And it goes from January 1st, 1990 to January 31st, 1990. And then you see we've got Y hat. And Y hat is your solution, really. That's what you want to see. You want to see the date and the solution. So what we did was we put this on an RMSE. And so the RMSE is 2.515. So that's your root mean squared. And so that was pretty good. That was a pretty good root mean square, 2.515, because what you're doing, you're comparing the forecast against the Y value. And then what we're going to do is we're going to put it on a data frame. So we put our Y value on a data frame so you can compare the actual value against the predicted value. And then we're going to put the prediction on a graph so you can see the prediction on the graph. I'm going to graph it some more. We're going to put it on some more graphs. And then now what we're going to do is we're going to put the prediction on Statsmodels. So we've got our naive approach, and here's the code for the naive approach, and you just get a straight line. So you can compare the naive against the Y value, and you had a root mean square of 3.99. Now we're going to check auto regression. And this is your auto regression. And you have a root mean square of 3.634. And now you're going to check moving average. And this is your moving average. And you've got a root mean square of 4.4975. And now we're going to check ARIMA. And ARIMA's got, and this is your diagram of ARIMA. And ARIMA's got a root mean square of 3.705. Now we're going to check simple exponential smoothing. So here's your diagram of simple exponential smoothing. And we've got a prediction, an RMS of 3.87. Now we check Holt's linear trend model. We've got an RMS of 14.885. Now we check Holt-Winter's exponential smoothing. And we've got an RMS of 4.065. So in this instance, FBProphet had less RMSE than Statsmodels. So in this instance, it's more appropriate to use FBProphet than it is to use Statsmodels. And that's why you always need to run your prediction up on several models before you select which model you're going to use, which is what I'm trying to do on something else. I'm trying to find out how to do something on Statsmodels, but it's very difficult because one of the problems is you don't get a lot of documentation, and so you have to go onto Stack Overflow, and you have to ask questions at Stack Overflow and ask people to help you. And I know I asked a question one time, but they don't want you to keep asking the same questions over and over again. So I'm trying to use code that's already out there on the internet to work on this other Statsmodels problem. So that concludes this code review. We did a code review on FBProphet and Statsmodels, and we decided that in this instance, FBProphet is a better model to use because it has less RMS E than Statsmodels. So this concludes our presentation. If you like my video, please like, subscribe, and share. If you want to keep receiving videos, then please tap the notification button and you will be notified whenever I make a new video. And if you like the work I do and you want to make a donation, I've got my email account to my PayPal account on the description box down below. And the reason why is because I don't have enough subscribers to monetize, so I have to ask for donations on this account. So thank you so much for watching this video, and I look forward to making other videos for you in the future.